Well, everybody, welcome to my presentation, TCP client server written in Python for ethical hackers and pen testers. The real life work of a penetration tester might become a bit routine when it comes to poorly configured and protected networks, which is often the case with smaller companies. But if you penetrated a more advanced, professionally maintained enterprise target, it's a completely different story. Very likely you'll have no tools to execute network attacks and no way to install anything to make your job easier. Sometimes you'll find yourself missing the absolute basics, like the ability to copy and paste or connect to the internet. But you'll be surprised how often you will have a Python install. So this presentation has two parallel goals: to show you the power of Python for cybersecurity and to demonstrate how to build a simple but powerful TCP client server system, which might be useful for lateral movement as well as reconnaissance during pen testing. Python is a high-level general-purpose programming language, and its philosophy emphasizes code readability with the use of the offside rule. Python is often described as a batteries-included language due to its comprehensive standard library, which you will see in a couple of minutes. Python consistently ranks as one of the most popular programming languages, especially for the field of cybersecurity. Oftentimes, during penetration tests, ethical hackers need to simulate a TCP client to test for services, send garbage data, fuzz, and perform other tests. When you don't have the luxury of using networking tools or compilers, the ability to quickly build a TCP client comes very handy. Creating a TCP server in Python is not much harder. You might need one to write command shells or create a proxy. In this particular presentation, we'll make the client and server talk to each other and exchange data from two different machines. We will create both the TCP client and server using the socket module built in Python. The module is first imported, and then programmers can call related methods. Well, now let's see some code. So first, this is the client script. I use some extra formatting, as you can see here for readability. When we run the code, you'll see why. But in real life, you'll probably use a simple bare-bone version of that. And I will also show that in a couple of minutes. As you understand, hackers are not very interested in how it looks, but how it works mostly. So in this particular program, we import the socket module, then set target ports in the target port in the IP address. We create a socket object, connect to the server, send data, and receive the response from the server. And here's the TCP server that will receive data from our client. I did some really detailed comment in here, so the person who doesn't know anything about programming or coding, they will actually be able to understand what specifically is happening there as they read the program. My actual demonstration consists of two parts. The first one was pre-recorded and is available on YouTube, which you can check out later if you want to. And the other one is going to be live, and I'll show you a couple of extra examples. So first of all, I created two Linux machines, Kali and Ubuntu, and I put them on the same network, which was kind of an undertaking in itself. This is the IP address of the client machine. And right now you will see the IP address of the server, which is also used in this program, and you will see why pretty soon. So let's take a look at the programs. I removed the comments, and what you can see here is the actual script, but it's not the most simplest form, which you will see later as well. And on this side of the screen, you'll see the server in a different machine. And what specifically it's doing here, I kind of explained already, but the difference here is that it also imports the threading module, which allows us to create several connections at the same time and use them in parallel if needed. So let's see how it actually works. So first we run the server, and it starts listening on this port right here. The IP address is the standard embedded internal server IP address. And the other machine is going to contact it in a second from the client. As soon as we run the program, it connects to the IP address that I showed you earlier. And as you can see, the server actually accepted the connection. Now, I'm typing in something that I'm sending to the server, but there's also another part that was pre-installed in the program. So as you can see, the string I typed was received by the other machine successfully. And this is the connection that was created on the port. And this is the part that was actually embedded in the program that you saw a second ago. Now, the server responds to the client with the very familiar word, which is here definitely received by the client. And you can only imagine what we can do and how many applications can be there. If we run this program again, it contacts the same IP address. The server accepts the connection and creates the connection on a different port, as you can see. So this is the original port, and this is the new port below there. And then here's the point of what I'm typing is that I'm just trying to show you, I'm sending a string to this server, but I'm trying to show you that basically anything can be sent there. And if we make this program a little bit more sophisticated, we can send files or whatever we want. Again, this is the part that was embedded in the program, and the server again responds, and the client receives the response. And we can go on and on and on. Now, if you guys want to try this at home, there's actually a simpler version of this. You don't need two machines. This is the simplest possible version of the program, which you can run inside your Ubuntu machine. You don't even need two machines for that. You can just run this in two different terminals. So here's the live presentation of that. We run the server. Well, actually, this is the program that I wanted to show you. And now we run this program. As you can see, it starts listening on this port. And now we are running the client. There is no bells and whistles here, nothing fancy. So it simply receives the acknowledgement from the server, and the server receives whatever was embedded in the program. And we can do this as many times as we want up until the setup limit that I set up myself, which is 7. And then if we go over this limit, the program will reuse the previous connections. Now let me show you something interesting. Here, this is the simplest version of the same TCP client, and I'm contacting my own old website on port 80. And as you can imagine, you can change the port to anything, and this way test something else that we discussed earlier in this class. And the only significant difference of this is that what we're sending to the server is a pre-configured string that imitates an HTTP GET request to the server, pretty much what your browser would send there. It's really simple. If you know what you're doing, you can type it yourself in a second without having any tools. And let me show you in a second how it looks in real life. So let me show you the program first. So this is the program that I just showed you. And now we're gonna run this program. Well, as you can see, it received something really familiar from the server. It even has the cookie, as well as some HTML and JavaScript that I used during writing the website a long time ago. Well, just imagine what you can do with this stuff. As we have shown, even without having any hacking tools handy or obvious vulnerabilities in the system under assessment, a pen tester can almost always use some simple tools written in Python to establish connection and exchange data between two computers on the network, implement a TCP server or client to test remote applications. You can try this at home. I posted direct links to the actual files that you can download and try. How about mitigation? Well, the good news for ethical hacker is that Python is not generally considered a system vulnerability or a threat. Linux comes with already pre-installed Python, and sysadmins know that it's not advisable to uninstall it from a Mac machine or a Linux. Well, installing Python on Windows is pretty easy to do, so that's not a problem as well. So if you master Python programming in the context of this presentation, you'll have a huge advantage and flexibility as an ethical hacker. Then what should we recommend the system admins out there? Well, guys, stick to the fundamentals and best practices, some of which I described in detail on this slide. These are some of the books I used and some of the website, and I highly recommend everything, especially the other section that you can see here down below. And thanks much, everyone. I hope it was interesting, and thanks everyone for this great class. I really appreciate everyone's work. This was really great. If you guys have any questions, feel free to ask.
That you playing guitar?